In this first example problem, we have a circuit containing 4 resistors, and we are asked to determine the equivalent resistance of these 4 resistors and to find the current that is flowing through the 18 ohm resistor. When I look at these 4 resistors, I recognize that these 4 resistors together are neither in series nor in parallel with each other. However, if I look at subsets of these resistors, I can find some resistors that are in series or parallel. Specifically, the 3 resistors on the right, the 18, the 9, and the 6 ohm resistor, are in parallel with each other. So first I will combine these 3 resistors into a single equivalent resistor. I could write 1 over R equivalent is equal to 1 over 18 plus 1 over 9 plus 1 over 6. In order to solve for R equivalent, we will need to find the least common denominator of the 3 terms on the right. 1 over 9 is the same as 2 over 18, and 1 over 6 is the same as 3 over 18. So I could write 1 over R equivalent is equal to 1 over 18 plus 2 over 18 plus 3 over 18. Because I have the same denominator in every term on the right, I could just add the numerators together, and this will be equal to then 6 over 18. I then could write 1 over R equivalent is equal to 6 over 18, which is equal to 1/3. And when I invert the left-hand side and the right-hand side of this, I find R equivalent is equal to 3 ohms. So these 3 resistors in parallel will behave identically to a single 3 ohm resistor. I will now draw the circuit again, but with the 3 resistors in parallel combined into an equivalent 3 ohm resistor. So when I draw that picture, I will have my 30 volt battery, I will have the new 3 ohm resistor in my circuit, and because I did not do anything to this 12 ohm resistor, I will just copy it into my new picture. So there is the 12 ohm resistor. When I look at this circuit now, I see that there are 2 resistors in series with each other. I could combine these 2 resistors in series into a single equivalent resistor by adding their resistances. So the equivalent resistance of these 2 resistors will be R equivalent is equal to 12 plus 3, which is equal to 15 ohms. I could then draw this circuit as a single battery and a single resistor whose resistance is 15 ohms. We then find a circuit that looks like this. In part B of this problem, we are asked to find the current that's flowing through the 18 ohm resistor. Our strategy in part B will be to look at the circuit containing 1 battery and 1 resistor. We will use our knowledge of current and voltage in a circuit and Ohm's law to determine the current flowing through this resistor and the voltage drop across this resistor. After we find that information, we will move backwards 1 step when we were condensing this circuit. So then that means we would be looking at the circuit containing 2 resistors, and we will again use Ohm's law and our knowledge of current and voltage in circuits to determine the voltage drop across these resistors and the current flowing through these resistors. After we have all that information, we will again move 1 step backwards in condensing the circuit, and we will use our knowledge of currents and voltages in circuits and Ohm's law to find the currents flowing through these resistors and the voltage drop across all these resistors. In a manner of speaking, you could think of part A of this problem as condensing a circuit down into a single resistor and a single battery. And in part B of this problem, we unpack that circuit 1 step along the way and apply Ohm's law and our knowledge of currents and voltage until we get what we are trying to solve for. Looking at the circuit containing just the 30 volt battery and the 15 ohm resistor, we could conclude that there will be a drop of 30 volts across the 2 ends of this resistor. Using Ohm's law, V equals IR, we could find the current flowing through this circuit. I would write V equals IR. The voltage drop across the 2 ends of this resistor is 30 volts, and the resistance of the resistor is 15 ohms. That gives me a current flowing through this circuit of 2 amps. If I draw the current flowing through this circuit, here is that 2 amp current. and I compare this circuit to the next circuit one level up as we are unpacking our circuits, I could reason that the current flowing through this circuit must be the same as the current flowing through this circuit. Therefore, I could draw a 2 amp current flowing through this circuit. And again, using Ohm's law, we know the current flowing through these resistors. We know the resistance of these two resistors, so we could find the voltage drop across these two resistors. The 12 ohm resistor will have a voltage drop across it given as V is equal to 2 times 12. So that will be 24 volts across this resistor. And the 3 ohm resistor will have a voltage drop of 6 volts across it, from V is equal to 2 times 3 ohms, which gives me 6. So the voltage drop across this resistor is 24 volts, and the voltage drop across this resistor is 6 volts. We now have the current flowing through the resistors in this circuit, the voltage drop across the resistors in this circuit. So we will compare this circuit to our original circuit in this problem. Looking at the original circuit in this problem, we again have the 12 ohm resistor that has a voltage drop of 24 volts across it and a current of 2 amps flowing through it. And because these three resistors are in parallel with each other, they must have the same voltage drop across them. That voltage drop will be the 6 volts that we found here. So the current is going to come around in the circuit, but then split up between the three resistors. We are asked specifically to find the current that is flowing through the 18 ohm resistor. I could use Ohm's law to calculate that. We know that there is a voltage drop of 6 volts across this 18 ohm resistor. So I could say 6 is equal to I times 18, and I find the current flowing through the 18 ohm resistor is 1/3 amp. Now, if we wanted to, we could calculate the current flowing through the other two resistors that are in parallel as well. We have already answered what the question is asking for, but let's do that anyway. So through the 9 ohm resistor, there will be a current that is given by 6 is equal to I times 9, and I find the current flowing through the 9 ohm resistor is going to be 2/3 amp. And the current flowing through the 6 ohm resistor will be again found with Ohm's law. So I have 6 is equal to I times 6, and the current flowing through the 6 ohm resistor is going to be 1. Notice that the three currents flowing through the three resistors in parallel, 1, 2/3, and 1/3, add up to the current that is flowing through the 12 ohm resistor and the battery, 2 amps.